Thank
Okay,
you.
please
Thank
go
you,
ahead.
everyone. Thank you, Michael and CEC Seminar Series for giving me an opportunity to present. So my name is Samiul Hasan. Today, I'm going to talk about how data science can inform us about resilience in the era of rapidly intensifying hurricane. First, a little bit about my background. I did my PhD from Purdue University in 2013. Then I did a postdoc in CSRO from 2013 to 2016 in Australia. And then I joined UCF in 2016 as an assistant professor. And then I got tenured and promoted in 2022. My main research interest is about urban data science, human mobility, and transportation network modeling. I'm also interested about infrastructure disruption, especially how infrastructure interdependencies play a role during hurricanes. I'm involved with Future City Initiative at our department, also Urban Resilience Initiative. Some of my key achievements that I have received so far funding for 4 NSF projects, all of them are somewhat related about hurricanes. And I developed 2 new courses at UCF, and I'm also serving as an associate editor of several transportation and disaster management journals. So now about today's topic, what is a rapidly intensifying hurricane? It's a hurricane that has an increase in the maximum winds of at least 35 miles per hour in a 24-hour period. And whether this has implications for hurricane preparation, response, and recovery efforts. For example, officials will have much less time to assess risk and organize evacuation, and this can sometimes lead to catastrophic consequence. People will have much less time to evacuate, and consequently, more people will face catastrophic surges and longer infrastructure disruptions. So today I'm going to talk about how our research can address these challenges. So the first project I'm going to talk about is an NSF eager project, which specifically looked into how adaptive infrastructure system can be developed with considering rapidly intensifying hurricanes. So the objective of the project is to understand how emergency management challenges are evolved for a transportation perspective during a rapidly intensifying hurricane, and how we can understand the emergent human and social behavior during a RIH. So for this project, we collected data from Facebook, which shared their population data and movement data. And we analyzed the data for Pinellas County and Lee County. There are 2 counties, and the hurricane had a direct hit on Lee County. And we computed a metric called stay index, where the proportion of people who were staying in each of those locations. And when you looked at Pinellas County and Lee County, they have very similar pattern of evacuation. Some areas near the coast, a lot of people evacuated, but still some people were staying there. And then some people most of the people were staying in this area. Now, but Lee County had a direct hit in the hurricane. So when you look into a closer look about these 2 counties, we found that the stay index before the hurricane, there was like close to 1. Then as soon as the evacuation order started to issue, then the stay index started to drop. And as more people are evacuating, they were having much less stay index. But like there are not many areas with a stay index close to 1. So it was good that many people left. But when we compare this with Lee County had an evacuation order 1 time into later, and then that there were many places in Lee County that is stay index close to 1, and which would suggest that many residents of Lee County did not evacuate, and which give a catastrophic consequence. Lee County had the highest death toll during Hurricane Ian. So, which makes us ask question why does it take a long time to evacuation order to trickle down? So in our research, we built an agent-based simulation model. This is a simulation test bed for mandatory evacuation zone and non-mandatory evacuation zone. And we look into that how multiple information sources can complicate evacuation decision-making. And we run 2 scenarios where people trust hazard forecast only, and people trust both hazard forecast and observe their neighbor. And we try to find out if there is a difference between these 2 evacuation scenario. And what we found out that we also looked into that different types of hazard, wind and flooded. We could model those things because of our high fidelity of the agent-based model. And we found that if people rely on neighbor behavior, that would significantly lower evacuation participation, and also it will slow down the evacuation. So which is a significant consequence during a rapidly intensifying hurricane, because they might see catastrophic damage and more people will stay. So that brings us to the third point that I'm going to talk about, how to find out an infrastructure, decentralized resilience or infrastructure disruption. So this is a project that I am collaborating with 7 universities, and the lead of this project is Florida International University, and where the objective of the project is to find out, investigate the effects of hurricanes on the interdependent infrastructures, specifically the energy, water, and transportation sector. And we also want to look at how household and community level adaptation can be developed using some type of simulation model, and so that we can present some complementary pathways. So this project has many tasks. Specifically, our task was to develop a agent-based model of the socio-infrastructural systems so that we can model the interaction between these infrastructure systems. So a couple of years ago, I showed in this seminar series that we looked into the data of Twitter, data from Twitter. Then as the hurricane was approaching, there were more people were having power outage, and the same time they were having disruption in the drinking water. So back then we could develop models that could identify these disruptions from social media data. And then we came up with an idea that, okay, what if we add an infrastructure layer in our agent-based model? So we did that. So we have an agent simulation test bed in a neighborhood in Miami, and where we overlay the power network and the road network. And as soon as we overlay, we could simulate the damage of a hurricane. And then we can also simulate different types of strategy of recovery effort. So we could model that if a community starts with a component-based or outage-based strategy, how they can recover. So what we have found that if we consider the disrupted roads, then the disrupted roads can significantly affect power system restoration. And that is quite a bit longer. So sometimes if their roads are not accessible to restore power, that can take 2 to 3 days longer disruption. So this is, if more people are staying during rapidly intensifying hurricane because they didn't have enough time to evacuate, then more people will experience longer disruption, which will have some consequences as well. So that's the consequence. So there are 3 points that I said, that emergency officials will have less time to organize evacuation, people will have less time to evacuate, and more people will see infrastructure disruptions. So this is the consequence of rapidly intensifying hurricanes in our daily life will be significant, especially when we are dealing with resilience or infrastructure resilience or community resilience. So now I'm going to talk about the last item that I've been working on. So this is an intelligent mobility center that I have helped to establish in Lake Nona area. And I have collaborated with Mobility Insights, an Israeli company, and an Israeli university called Ariel University, and Travis Stock, who is the land developer of Lake Nona area, and Beep and Arkimoto. And the objective of this Intelligent Mobility Center is to create cutting-edge tools, a laboratory where we can develop AI-based tools and simulation models so that industry can readily use those tools. And also it will give our students an opportunity to learn, not from a classroom setting or academic setting, but from a real-world implementation setting. And we can also showcase some of those models or simulation tools that we are building here at UCF at the forefront of industry. So for example, this is a project that I did where I simulated the AV shuttle operation of Beep with collaboration with Beep. And Beep operates a shuttle in Lake Nona. If you have been there, you have seen. And that creates longer queues in their shuttle operation. And the shuttle actually operates in 10 miles per hour. And in our research, we see that if they want to increase the frequency or decrease the shuttle interval to from 30 minutes to 20 minutes to 10 minutes, that's going to affect their network speed because the shuttle operates in a much slower speed. So we want to ask the question about how to mitigate that network speed. So we found out that if a moderate increase in the shuttle, like 15 miles per hour in off-peak or 20 miles per hour in the peak period, will mitigate these traffic impacts. So in terms of some future research and collaboration ideas, so in short term, I want to focus on agent-based simulation testbed that we have been working for hurricane damage and recovery modeling. We want to build a digital twin for AV shuttle operations for Lake Nona area. And we have been funded for FDOT for building deep learning model for traffic incident management. In the long term, our goal is to develop digital twin and AI technologies for resilience, and transportation applications. And with that, I would like to end, and I would like to acknowledge my lab members present and the past, and also my collaborators in Dr. Mohammad Abdelati, Dr. Eluru, Claire Knox, and many from other departments as well, and the funding agencies, NSF, Florida DOT, and Mobility Insight, and data providers from Facebook and FDOT. So thank you all. So I will be happy to answer if you have any questions.